The French 75 and the problem with winning. The weapon the American artillery program was built around in the early 1930s was not even American. The French 75mm field gun had been the dominant light artillery piece of World War I, fast to deploy, reliable, and capable of sustained rates of fire that impressed everyone who used it. The American Army adopted it and then spent the next 2 decades struggling to move past it. The problem was not that the French 75 was bad, it was that it had become a ceiling. Decisions about new artillery development kept running into the assumption that the French 75 set the standard and anything new needed to be measured against it. That assumption delayed the development of genuinely modern replacements by years. By the mid-1930s, the French 75 was still in American service and still being treated as a primary weapon, despite being clearly outdated against the guns other countries were developing. The M1897 in American service. American batteries, operating French 70s, spent the interwar years in a holding pattern. The guns worked. Ammunition was available. Training was established. There was always something more urgent to spend the limited defense budget on than replacing weapons that technically still functioned. What was being missed was the shift in how artillery was being used elsewhere. Germany, the Soviet Union, and Britain were all developing heavier guns, longer ranges, and better fire control systems through the 1930s. The American program was watching but not keeping pace, partly through budget constraints and partly through institutional reluctance to abandon what was familiar. The M2A1 105mm howitzer. The right answer, finally. The weapon that would define American field artillery through World War II began development in the late 1930s. The M2A1 105mm howitzer was designed to replace the aging French 75 as the standard light artillery piece, and it did that job well enough to remain in service for decades. After the war ended, it could fire a 33-pound shell roughly 7 miles. It broke down into loads that could be moved by truck or, in difficult terrain, by pack animals. The split trail carriage allowed the barrel to elevate high enough for both direct and indirect fire. And it was simple enough that crews could be trained on it quickly, which mattered enormously for a military that was about to expand from 175,000 men to over 8 million. The M2A1 was approved in 1940. It arrived just in time, the 155mm and the heavy end. Alongside the 105mm, the Army was developing heavier options for targets that needed more than a light howitzer could deliver. The M1 155mm howitzer, sometimes called the Long Tom in its gun version, was the primary heavy artillery piece that American forces would carry into the war. At 155mm, it fired a shell weighing around 95 pounds, out to a range of around 9 miles in howitzer configuration. Further, in gun configuration, it was large, heavy, and required a dedicated truck to move. But for destroying fortified positions, cutting roads, and reaching targets well behind enemy lines, it was the right tool. The heavy artillery program in the late 1930s was underfunded and behind schedule. The guns that were coming would largely be good enough, but getting them into production in time was a closer thing than it should have been. The Fire Direction Center, the innovation that mattered most. The single most important development in American artillery during World War II was not a gun, it was a system. The Fire Direction Center, or FDC, was an organized method for receiving calls for fire from forward observers, calculating the data needed to hit the target, and transmitting firing instructions to multiple gun batteries simultaneously. It sounds straightforward. In practice, it was a significant organizational and mathematical achievement that allowed American artillery to do things no other army's artillery could do as efficiently. A forward observer with a radio could call in a target location. The FDC could calculate firing data for every gun in range and have all of them firing within minutes. Multiple batteries from different units, sometimes from different divisions, could be coordinated onto a single target without those batteries ever being co-located or having worked together before. The Germans called it Jabos when they referred to Allied air power and had specific German words for the feeling of being on the receiving end of coordinated artillery. What the FDC made possible was a concentration of firepower that felt to the soldiers under it like something much larger than it actually was. North Africa. Learning in the desert. American artillery first went to war in North Africa in late 1942. The results were instructive in both directions. Where American guns were properly positioned and the FDC system was functioning well, the firepower they delivered was effective and impressive. Where the system broke down, where forward observers lost communication, where the coordination between infantry and artillery failed, the guns sat silent while infantry fought without support. North Africa taught American artillerymen the practical difference between a system that works in training and one that works under enemy fire with communications cut and positions under attack. The lessons fed directly into how artillery units were organized and trained for the campaigns that followed. The M7 Priest artillery that moved with the armor. The problem with conventional towed artillery in an armored campaign was simple. Tanks moved faster than horses or even trucks could haul a gun into position, which meant artillery regularly fell behind during advances and left armor unsupported at the moments it most needed fire. The M7 Priest was the American solution. It mounted a 105mm howitzer on a Sherman tank chassis, giving the gun enough speed and cross-country mobility to keep up with an armored advance. The name came from British crews who noticed the pulpit-like machine gun ring at the front of the vehicle. The Priest went into service in late 1942 and reached North Africa in time to see the final campaigns there before moving into Italy and then Northwest Europe. It gave armored divisions an organic artillery capability that could actually keep pace with the tanks it was supposed to support. The proximity fuse, officially called the variable time fuse, was introduced to American artillery in late 1942 and began reaching field units through 1943. It used a small radio transmitter in the nose of the shell to detect when it was close to a target and detonate at the optimal height above ground rather than on impact. Against infantry in the open, an airburst shell is significantly more effective than one that detonates on impact and sends most of its energy into the ground. The proximity fuse made airburst reliable without requiring precise altitude calculations for each shot. It was kept secret for as long as possible and was initially restricted to use over water or enemy territory to prevent dud rounds from being recovered and analyzed. When it was finally used in the Battle of the Bulge in December 1944, German troops reported it as one of the most unpleasant surprises of the entire war. Italy and the limits of terrain. The Italian campaign beginning in 1943 was the hardest test American artillery faced during the entire war. The terrain was mountainous, heavily defended, and extremely difficult to move heavy equipment through. German defenders used the high ground with skill, and the standard methods for bringing artillery forward and establishing fire positions had to be adapted constantly. Mule trains carried ammunition up slopes that no truck could manage. Guns were disassembled and hauled up by hand in some cases. Observers climbed to positions that gave them line of sight over ridgelines that otherwise blocked every approach. What Italy proved was that the FDC system and the training around it were solid enough to function even when the terrain made everything else as hard as possible. American artillery in Italy could not always be positioned ideally, but it was consistently brought to bear on German defenses in ways that German commanders noted as a major factor in the difficulty of holding prepared positions. Normandy and the Bocage problem. The Normandy landings in June 1944 created a specific artillery challenge in the hedgerow country of the Bocage. The dense network of earthen banks, topped with thick hedges, broke the landscape into small compartments where line of sight extended only a few dozen meters. Conventional artillery observation became extremely difficult. The solution involved closer cooperation between infantry, tanks, and artillery than the standard system required. Forward observers moved with lead infantry units, sometimes into positions that were dangerously exposed, to maintain the ability to call fire onto targets that would otherwise have been invisible. The Bocage campaign was costly, But the artillery support worked well enough that when the American breakout at Saint-Lô finally came in late July 1944, preliminary artillery bombardments were central to cracking the German defensive line that had held for weeks. The Bulge. When artillery saved the line, the German offensive in the Ardennes in December 1944 came close to breaking through American lines in several places. What prevented it from succeeding in those places was often artillery. Bastogne became the famous example. The 101st Airborne Division surrounded there had limited ammunition and no relief for days. What they had was artillery support from guns inside the perimeter and, where possible, from longer-range guns firing from positions outside the encirclement. When German armor tried to push through the American perimeter, artillery fire was the primary tool used to stop it. The proximity fuse was released for general use during the Bulge, and German troops advancing across open snow found themselves under airburst fire that inflicted casualties well beyond what traditional ground-burst shells would have produced. After the battle, German officers captured and interrogated specifically mentioned the proximity fuse as one of the factors that made the American defensive fire feel qualitatively different from what they had faced before. The Pacific, a different problem entirely. American artillery in the Pacific was shaped by the specific problem of taking heavily fortified island positions defended by Japanese troops who had often had months to prepare their defenses. The answer in many cases was direct fire at close range, using artillery pieces as battering rams against specific fortified positions rather than as long-range indirect fire weapons. The M2 105mm howitzer was brought to point-blank range against bunkers and caves on islands like Iwo Jima and Okinawa, often while under fire itself. The Marines developed close coordination between artillery, infantry, and naval gunfire that was specific to the Pacific island hopping campaign and different in character from what was being done in Europe. The guns were largely the same. The way they were used reflected a completely different environment and a completely different defensive opponent.